Hello, I'm going to show you how to make a Sieve of Eratosthenes. And what a Sieve of Eratosthenes is it's a table that not unlike a times table chart that shows you prime numbers and composite numbers. And it was developed by a mathematician in ancient Greece named Eratosthenes. If you do not have graph paper at home, which you might not, you can use white paper, and I'm going to show you how to fold it. So I'm going to fold hot dog, hot dog, hot dog, so it's long and skinny, right? And if I fold hot dog that many times, I'm going to have 8 squares. Now I want to have a little bit longer, so I'm going to do hot dog one more time. So when I open it up, I'm going to have a lot of little folds, right? And the little folds are going to help me. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to have 10 little folds, and I only need to have 10 across. And then I can also fold it hamburger, hamburger. So if you don't have graph paper, you can kind of use this strategy to make your own. Hamburger again, and hamburger again. And it's going to give you sort of your own homemade graph paper. So I have a whole bunch of little squares that I can write in. And what you're going to do is you're going to go like this. 1, 2, 3. You can write in each one of these squares, right? I'm going to show you on graph paper because it's a little bit easier for you to see. So you can home make your own graph paper using white folded paper. You just have to fold it a whole bunch of times until you get 10 squares. And I'll show you on the graph paper. So I'm going to number. I'm going to zoom in a little bit closer so you guys can see a little bit better. So I'm going to write my name at the top of my graph paper. And again, if you're using the homemade graph paper, you can write your name at the top of that too. And then I'm going to make a hundreds chart basically. I'm going to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40. So Eratosthenes was an ancient Greek mathematician, and he loved numbers. He loved seeing that numbers formed patterns. He was really obsessed with patterns. So if as you start making your chart, you can start seeing patterns. These all end in 2. These all end in 3. These all end in 4. These all start with 2. These all start with 3. These all end in zeros. These all end in 9s, right? So he started noticing a lot of different patterns. Right? And he started noticing these all end in 1s. So we're going to keep going. This is when you're a little kid, like when you're in first grade, this is called a hundreds chart, right? And this is one way that teachers will often test to make sure that kids know how to count to 100. Make me a hundreds chart. And you will sit there and make a hundreds chart. Okay, I'm almost to 100. Once you get to 100, I'm going to put a little line around this. Just kind of right here and here on the edge. So the reason why this is called a sieve is because we're going to look at numbers that have more than two factors, and we're going to color in. We're going to use crayons to color. And so first thing I'm going to do is I'm going to leave one blank, and I'm going to leave two blank, and I'm going to leave the first few numbers blank. And then I'm going to take every single even number. I'm going to take every single even number and I'm going to color it in with one color. So an even number is always going to be divisible by 2. So if I have numbers that are divisible by 2, I'm going to color them in purple. So I'm going to leave the number 2 blank though. So I'm not going to color in the number 2, but I'm going to color in every number that's an even number. So I'm going to color in 4. I'm going to color in 6. I'm going to color in 8. I'm going to color in 10. And then I have 12. 14. And then I start to notice something, right? What are you noticing as you're coloring in these even numbers? What do you start seeing happening? It looks to me like I'm making stripes, right? That I have every number that ends in 2, 4, 6, 8, and 10. So I'm noticing that all of these are even numbers. I'm going to put some paper because my desk is wooden and it's very scratchy. So I'm going to put some paper underneath it so that when I color it, it looks a little neater. Okay, so I have all of these are even numbers, and they're all divisible by 2. If I were skip counting, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. If I skip counted, all of these would be even numbers, and they all line up evenly striped. So I'm just coloring these in to make them striped. I'm going to do the next row. And again, if you're using the folded white paper, you can just color over using that paper as well. So Eratosthenes started noticing that when he lined numbers up, that he was seeing a pattern. This is basically the purples are evens and the whites are odds, right? Every other number is divisible by 2. So we're basically looking, we've just made purple or whatever other color you choose, all of the numbers that are divisible by 2. Ta-da! We left 2 blank, and I'll tell you why in a little bit. Okay? Now we're going to look at numbers that are divisible by 3, and I'm going to pick another color out of my crayon box. I'm going to pick orange. Orange, you glad I picked orange. So I'm not coloring 3, but I'm going to skip count. 3 times 1 is 3. 3 times 2 is 6. That's already colored. 1, 2, 3. So I'm coloring 9. 1, 2, 3. Already colored. 1, 2, 3. I'm coloring 15. 1, 2, 3. Already colored. 1, 2, 3. I'm coloring 21. 1, 2, 3. Already colored. 1, 2, 3. I'm coloring 27. 1, 2, 3. Already colored. 1, 2, 3. I'm coloring 33. Right? Because 3 times 11 is 33. 1, 2, 3. Already colored. 1, 2, 3. So I'm just skip counting by 3s. I'm coloring all of the multiples of 3, but I'm not coloring 3. 1, 2, 3. Already colored. 1, 2, 3. I'm coloring 45. 1, 2, 3. Already colored. 1, 2, 3. I'm coloring 51. 1, 2, 3. 1, 2, 3. Coloring 57. Are you guys starting to see a pattern? I'm starting to see some diagonals that are moving down this way, right? 1, 2, 3. 1, 2, 3. Also, you can kind of see that there's 2 numbers in between each, right? There's 2 numbers in between each orange square. So I can kind of color ahead and do that. One, two, three, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. All right. I definitely see a pattern, right? I'm seeing some diagonals. So now we're going to skip count by fours. I'm going to pick another color. I think I'm going to pick, I love green, so I think I'm going to pick green. And I'm going to pick a beautiful green crayon to do that with. So now I'm going to look at fours. 1, 2, 3, 4, already colored. 1, 2, 3, 4, already colored. 1, 2, 3, 4, already colored. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Why do you think they've all already been colored? Because all of the multiples of 4 are even numbers, right? And we already colored all the evens when we did the 2s. How about 5s? If I leave 5 blank and then I go to 1, 2, 3, 4, 5, already colored. 1, 2, 3, 4, 5, already colored. 1, 2, 3, 4, 5, already colored. 1, 2, 3, 4, 5. Aha! Not already colored. So all of the multiples of 5, 1, 2, 3, 4, 5, already colored. Then 35, right? Then 40, then 45, then 50, then 55, then 60 is already colored, then 65, then 70, then 75, then 80, then 85, 90, 95. So these two. Okay, so now I have all the multiples of 5 colored. How about multiples of 6? I'm going to get another crayon out. Let's see, what's going to go good with this? Maybe a pink would be nice with my color scheme. So now if I'm looking at 6, if I skip count 6, 6, 12, 18, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So there weren't any. And here's the reason why. If you have a multiple of 2 or a multiple of 3, then you have a multiple of 6, right? So 6s are all taken care of. Let's do 7s. Let's see if we can count by 7. Here's 14. Here's 21 is colored. 28. 7 times 5 is 35. 7 times 6 is 42, right? 1, 2, 3, 4, 5, 6, 7. 1, whoops, this one right here. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Ooh, 91. So those are all multiples of 7. 1, 2, 3, 4, 5, 6, 7. And then there's no more. Okay. So I'm going to, I think I may have all of them. We need 8s next, right? So if I count by 8s, let's see. 8, 16, 24, 32, right? I think most of them are going to, most of the 8s when we got the 2s, that's going to take out most of the 8s, right? So I think we have all of them. Let's check if we have all the 9s, right? If we have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 and then 99 over here. So all the 9s are covered. So what this chart shows you is all the ones that are colored are composite numbers. So I'm going to write on here, I'm going to make my chart a little bit bigger. And then I'm going to write on here colored equals composites. White, the white numbers are prime numbers. And then I'm going to take my scissors and I'm going to cut out my Sieve of Eratosthenes. And again, if you have the white paper that you folded into little squares, you can cut that out as well. Oops. And there you have your very own personal prime and composite number chart. So we know that prime numbers are only divisible by 1 and themselves. Composite numbers have many factors, right? They usually have more than just the 2 factors of 1 times the number, right? So an example of this would be if I wanted to say, well, let's say that I want to find all of the factors of 24. If I wanted to find all of the factors of 24, there are a lot of different ways of getting 24, right? 1 times 24, 2 times 12, 3 times 8, right? 4 times 6. So there are many, many factors to 24, and that's why it is shaded. If I wanted to find the factors for 5, all I have is 1 times 5. That's it. There are no other factors. And that's why this 5 is a prime number and 24 is a composite number. So Eratosthenes figured that out just by using some ancient crayons. I'm sure he didn't use crayons. Crayons hadn't been invented when he was alive in ancient Greece. But he figured out by shading in a pattern, he realized, oh, okay, I can make this hundreds chart and I can make it into a prime and a composite number chart. And just by adding some color and knocking out all of the factors, and then the prime numbers stay in the sieve. I don't have to color the prime numbers. So I have one of these charts in our classroom. We usually make one in our classroom, like a large one, so that you can look at it during class, but it's also really good to have your own personal copy. You can also print out your own copy online if you Google Sieve of Eratosthenes. Eratosthenes is kind of hard to spell. Very hard to spell. But now you have your own prime number chart. And if you use the folded paper, you're still going to cut it out and you can still have your own prime number chart. So I hope you enjoyed learning a little bit about prime numbers and composite numbers and how they work. Once you've made this chart, you can use it when you're doing your homework. It's very helpful, so I hope that you enjoyed coloring your own Sieve of Eratosthenes.